Okay, cool. Okay, welcome back. Well, if anyone's actually watching this at all. Um, so last time I was doing some comparisons with logging libraries. Also, not feeling super well right now. Um, I don't really know what's wrong with me right now. I guess it's partly because I didn't get very much sleep yesterday night, and kind of may have pushed myself a little too hard today. But yeah, feeling a little physically unwell. But otherwise, I think I'm good, and I've made some decent progress. Last sprint, I closed a task. Um, this research one on logging. So that means, of course, I did make a final decision on that, and I want to actually talk about that today, just to kind of document the decision making behind that, because I feel like it's something worth talking about. So let's get into that. Oh, I wasn't prepared for this. Let me just shrink that down. Yes. So, I was reading a book about dependency injection in C Sharp. I think it's literally called like a dependency injection in C Sharp or something. I don't remember what it was called, but yeah, it was a C Sharp book on dependency injection. It's published by Manning. I don't remember the exact title anymore. But this situation came up about logging frameworks, and in particular, how logging frameworks expose these like static log managers, where you can call this like get logger function, and you pass in the type of the class you're in, and it gives you like a particular logger for that class. And then you can just use it as follows. And this is a very common sort of API. You see this a lot in Java. You see it in C Sharp. I think Scala has some wrappers for like log4j and other such libraries. And they also, follow that. Well, mostly because, if you're using like SLF4j, then as like your logging facade, that's kind of you generally are kind of stuck with like the same sort of API, even in Scala land. And the book is actually saying that this is an anti-pattern. So they say that this creates something called an ambient context, and the main reason why a lot of logging frameworks expose this like global or like this static log manager here is because it makes it easier to avoid injecting a logger dependency through the constructor of all your classes. So you could just add like another field to the constructor for message generator, for example, here. And this is an example from the book. Uh, if you could add a field here for the ilog logging interface or logger interface, and then you could use that for logging. But of course, the argument here is that no, you don't want that. Instead, you should just call this global logger thing, so you can avoid having to pass this logger dependency around all over the place in your application, and that's really annoying. And that is one of the complaints that we saw when we were looking at the slog libraries. A lot of people were complaining about that. They don't like passing around a logger everywhere. So yeah, it's sort of like global versus I guess non-global logging. Like, do you treat logging specially? Do you give it like do you treat it with like special case where you have this sort of ambient context? And here's the reasons that the book actually outlines for why this is actually bad. This actually might be a little bit small. I just realized. Yeah, I usually bump up the text size, but essentially they say that this kind of hides your dependencies. This can make it easy to hide the fact that the single responsibility principle has been violated. So if you're familiar with like the OOP solid principles, you're probably well familiar with what SRP means. Yeah, I actually find that the solid principles apply to more than just object-oriented languages. Like interface segregation, for example, is something that definitely affects even like um, functional EDSLs, since they kind of scale in the exact same way that um, interfaces do in object-oriented languages. So, yeah, this is basically outlining that it hides the dependency on the logger, and if you have other sorts of ambient contexts, then you're hiding even more dependencies. This also leads to temporal coupling. So I've seen a couple of different definitions of temporal coupling, some to do with like threading, and that leading to like data races and stuff, or race conditions. But in this particular case, temporal coupling is referring to when you have to call one method. Usually it's like an initialize function, and if you see like a .init method on a class, usually it's a telltale sign of temporal coupling. But you have to call some kind of initialize method on some class before you're allowed to use it. And yeah, in this case, you have to initialize the logger before you can start using it. Otherwise, when your app tries to use the logger, it just dies. And I think I've actually ran into this in production once, because yeah, working with Scala, this kind of stuff can happen. So that is one of the big drawbacks of ambient contexts like this for logging. This one that we have here, right up here. The book says that we prefer to fail fast instead, so it'd be nice if we could just crash immediately rather than crash partway through usage, because I mean obviously that's a lot more likely that'll slip into an actual release. It's harder to catch that. So yeah, it's this is important to know. It also makes testing more difficult because it adds a global state. I guess I'm not actually sure what they mean here. I guess you can configure the logger in particular ways, and yeah, they're talking about how it can ruin parallel test runs. Like, I understand, like, in general, how ambient context can ruin parallel test runs, because if you have a global state, you change the state in one test, then the next test is kind of relying on that first test having been run first, and so you can't really parallelize the tests very easily if you do that, because now you can't guarantee the order that the tests are run in anymore. I don't really know how that affects logging in particular. I think they're just talking about ambient context in general with this, but yeah, and they also talk about how it can also mess up sequential tests if teardown doesn't undo the changes that were made to the global state on a per test basis. And that's also a fair point. And the last thing that they outlined was that it makes it hard to provide different consumers with different implementations of the dependency. And of course, they go back to the getLogger API here. It requires the consumer here, the message generator, to pass in this type information in order to get the implementation of the ilog interface that it needs. So yeah, they're arguing that this is needlessly complicated. So I looked at this. I went back over this with a fine-tooth comb just to make sure that I'm making the right choice with my logging library here. And obviously this isn't like the only source of feedback that I could have looked at, so bear in mind these are kind of like my rough thoughts. I don't want to spend forever looking into logging, okay? And this was just like the first resource that really came to my mind when I thought about this and potential risks. Sorry, I kind of lost track there. So here's the proposed solution that the book has for solving this logging issue. Their proposed solution is actually to use aspect-oriented programming. The way that works is you can add like a decorator. It's like a logging decorator, and you can use it to wrap any service that you pass it. And yeah, you just have like a single place where you have to pass in your logger, or where you have to use your logger even. And all it does is it takes any request to the service and serializes it into a string, and then logs that with any additional information, like, you know, the time or whatever, like stuff that isn't dependent on the actual operation that's being done. So you can you don't really you don't really get information, um, I guess, about the context. You only get really the state, or like the state of the request that's being passed into the service, or being sent to the service, I guess, like the actual request or command. But yeah, that's generally all that you really need, at least according to the book. That's what they were kind of arguing for. It's like, you don't really need any other debug information. You don't need to like put a info log at the beginning of every method or anything like that. You can just, you know, log the state of the input argument that's given, and that's enough. So I thought that was kind of interesting. It certainly means that you don't have to, you know, have a separate logging wrapper for every single different class you have, or every single different service. That can kind of make things a little bit more scalable, because then you only have one real like decorator per cross-cutting concern. So like other cross-cutting concerns they're talking about is like are like security, or, you know, making things into transactions. So you could have like a single decorator for each of these cross-cutting concerns, and yeah, you can just apply that cross-cutting concern to literally any service you want. You can apply as many as you want, as few as you want. You can mix and match, right? Like, it's a pretty interesting approach. Definitely not something I was ever familiar with before. So, yeah, I could talk about that more. I'm probably going to talk about that a bit more, even, actually. Maybe in a separate video. I don't know. But anyway, that's kind of beside the point here, because I'm assessing libraries. I mean, this may have been relevant. This actually might still be relevant. I don't know. So I was looking at the tracing library in particular, because I've kind of decided I don't really want to use slog, but I still wasn't really sure at the time if I was going to even use tracing, or if I was going to try like the AOP thing with my own like logging solution. I don't know. And, you know, there are some risks to using the tracing library, at least, you know, if we go by the feedback from this book. So the tracing library is global, so you do have that sort of global ambient context. It could impact testability, like the whole parallel test runs thing, if for some reason I, you know, mutate that state somehow. I don't really know if you can, come to think of it. So maybe that's not such an issue, but again, like, I don't really know. These are just rough ideas that I was kind of, you know, laying out. Again, yeah, it does create an ambient context still. So it does come with some of the other drawbacks, like the temporal coupling, right? For the tracing library, you still have to initialize it. Like, maybe I can even just like show that off real quick here. I was playing around with this a bit yesterday. Like, and I still haven't fixed my Rust analyzer. I'm great at, you know, finishing tasks and stuff, not moving on to new things. Like, you have to call this .init method here, and again, like, that is the telltale sign of temporal coupling, because if you don't have this defined, then it's not actually going to do any logging. So you actually have to make sure that you do this tracing subscriber init first before you do anything else. And the compiler won't stop you. That's the thing. The compiler doesn't stop you. If this was Idris and you had dependent types, you might be able to encode that in, like how you can with free monadic EDSLs. But in this case, I don't know if you can do that. Excuse me. So, right, it might hide dependencies and complexity. Again, that's another, that kind of falls under ambient context, right? Like, that's one of the things they outlined. Another thing that I think might be a problem is if I want to switch to a different logging framework or library later. Now, some of the libraries, macros are pretty universally accepted across multiple different, I guess, logging frameworks. And you know, they like the info macro and like the debug macro, those kinds of macros, like these ones, error, info, the ones that actually do the logging, they're pretty common. Like you'll see other libraries like log and slog that have that exact same API, and it might be because they all implement the same logging facade. I actually don't know. I think that might be the case, but yeah, I'm not really sure how easy it is to switch to a different logging library when you have stuff like tracing a subscriber sitting here, and you know, maybe this stuff needs to be kept in like implementation code and not in my business logic. But business logic is generally where I want to be doing logging. So yeah, it's kind of tricky. It's very tricky. But like I can certainly initialize this in like my main rocket method. Like the ignite method, I think is what it's called. I forget what they call it, or is it launch? Um, yeah, I might be able to do that there. Of course, they have a procedural macro on that, so I'm really not sure what they actually do with that method. But yeah, I think that should be possible. And then for the rest of it, I can just, you know, throw in info and error uh, macro calls. There are other issues, but I'll get to them in a moment. So there are some differences from the static log managers. Um, so that temporal coupling issue is still there, but um, it's less of a problem, at least as far as I can tell. So the main issue that the author had with uh, the temporal coupling created by ambient context is that your application might just crash upon first usage of a certain class instead of crashing immediately at the start of the application and letting you know that, hey, you didn't initialize the logger yet. In this case, in Rust, with tracing, it actually doesn't crash at all. Like, if you forget to initialize, it it just doesn't even log. Nothing, no logs will come through. So that's interesting because it does mean that you don't have that issue with crashing, and so that's not or like crashing later on. It just doesn't crash at all, which is nice. That is definitely nice. It is still kind of a problem that you can forget to initialize the logger at all, and the compiler won't stop you. But I think at least, you know, at the end of the day, you're not going to see any logs, and it'll be very obvious that nothing is being logged. And so you'll be like, oh, I forgot to initialize the logger. So that shouldn't be, that really shouldn't be too much of an issue or a hassle to debug. I also don't think testing will be that complicated. This is just my thoughts. I actually don't know. But yeah, I don't think we'll need to do any logging in our tests. So if we don't need logging, we can just not initialize the subscriber. And if we don't do that, we don't get any logs. And we don't have the same issues with global mutable state that Java tests do. At least I don't think we do. So there might be issues with that. I don't actually know. But I'm thinking because Rust tests are generally top level functions within some module, you don't really have to worry about, you know, having a shared context or like a shared logging subscriber between multiple different tests, right? Like you'd create your logging subscriber inside of the test that you're writing, and then you would just drop it at the end of the scope, at the end of that test, and so then the next test would run with a different one. And I think that you would be able to run them in parallel, and there shouldn't be any issues. I mean, as far as I know, Rust has some pretty strong guarantees around data races. Like they can't happen due to the mutable aliasing rules in Rust, so I really don't think this is actually going to end up being a problem. Unless they do some like crazy unsafe. No, they wouldn't, because like that's undefined behavior, right? They consider that UB. They wouldn't let you do that. So you shouldn't be able to. So and if a safe API allows you to like, if a safe API exhibits UB, then I don't think it. But unsafe is just a keyword that gives you superpowers. It's not really you like it gives you auditing powers. I don't know. Whatever. Anyway, this is getting into territory of stuff that I doubt is going to be a problem. So there's that. Right, providing different consumers with different implementations. Yeah, okay, so this isn't complicated at all by passing in type information. Because quite simply, we never have to do that anywhere, ever. There's not a single place in here where I have to pass in, like, type information or whatever. So that's not an issue in the slightest. Yeah, you can override the default global logger in the consumer. Yeah, if you want to provide a different implementation, they have options like this, right? So here I create a collector. Actually, I think that, yeah, I call it collector because I think the latest master for tracing calls them collectors, and there's like a collector module, but in this version that I have, it's called subscriber. Anyway, it's confusing. But you can create a different one from the base one. And so this code will use this one. Any code inside of here, though, will use this collector or subscriber, and we'll call foo inside of this scope. And yeah, you'll see that it only will print error instead of info. So that's pretty cool. I do like that. I think this is a pretty nice way of handling the I need like a special implementation of the logger at this particular location. You can just, you know, create your own tracing subscriber and just pass it into this method here, and now you're in a context where you have that. And it uses just plain overriding for that. Yeah, that's pretty much how that works. So I would say that it dodges most of the issues of ambient context. At least, you know, from my, I guess, somewhat cursory amount of research that I've done here. So my final decision was that I will be using the tracing library. To me, slog is just not really a competitor in this case at all. I mean, I know people are saying slog is better because it's not global, and global logging sucks. Obviously, those people kind of subscribe to this sort of mentality. Maybe they also have used AOP in the past, and that's something that they prefer. And, you know, I get that. I get that. But slog is more complicated, at least from what I could see. You know, just at a glance. Which may not be fair to it, but whatever. The real thing, the real kicker there is it's just not as well supported. It's not as popular, right? We've got, I think, the Rust Lang team, or like one of the Rust core teams, is using tracing, and they're not using slog for structured logging. And tracing also covers asynchronous logging as well. And that's a pretty big use case for a lot of people. So tracing is starting to look like it's the logging library to use if you want structured logging. And yeah, it kind of is the only game in town. So if I'm gonna have to pick a logging library, I think tracing is the library that I'm gonna use. It was either use tracing or, you know, go with the global loggers are evil crowd and just not use tracing at all, and maybe use slog instead and actually try and like figure that out. One of the reasons actually why I decided not to go with slog is because my current design already isn't very aspect oriented, and I'm not immediately sure how I would convert to a more aspect-oriented design. I mean, I have some ideas. Um, but yeah, just I don't really think it's that big of a deal to have the global logger, or like the global logging system. But yeah, I mean, I don't know. It could bite me in the butt later. I just don't think it will. You know, I don't think this application is big enough for that to really make a huge difference. And there are a lot of projects that are already using tracing. So maybe the issues that the book raises here, while I think they are valid, I guess, complaints about ambient context and static log managers and global logging systems, I don't think it's actually that big of a deal at this scale. Maybe at like a really big scale when you're working on like a, you know, huge enterprise project. Maybe that kind of stuff matters a lot more. Again, a lot of those issues that he pointed out were also issues that are very specific to these object-oriented libraries, right? Like passing in the type information, like the crashing and stuff. Like that's not something that happens with tracing. So, I don't know. It is interesting. I don't really know if I'm making the right decision here, but sometimes you just can't. You can't just sit around and decide on what to do all day. So yeah, that's I think I've made clear why I'm choosing what I'm choosing. Obviously, you know, I could have done more research. There's certainly more to look into there. But I think I'm good with what I've figured out thus far. I'm good with making the trade-offs that I'm going to be making by picking tracing. Like, I'm picking a well-supported solution, and a solution that will likely be supported uh, in the foreseeable future, right? Like, that seems like a better choice than just, hey, I'm just going to pick up slog because this guy who wrote this book said global logging systems are evil, and then end up having to deal with, oh, slog has now become deprecated or something. Like, that would really suck. I think that'd be a lot, a much worse outcome. So, yeah, we're just gonna go with the, I guess, pragmatic option here, and we'll pick tracing. So that's pretty much it for today's stream. I didn't really have anything big planned. I just wanted to talk about why I've decided to go with tracing. It seems like the logging library to use these days. I haven't seen much buzz around log anymore. slog is far less popular, and I actually don't know of any other logging library. I guess that was like Fern, I think. Well, I think that was very specific to Rocket, though. And yeah, that was like... I think that might have been structured logging as well. It might have been an implementation of slog, but yeah, it doesn't really matter. Seems like tracing is kind of the way to go these days. And I mean, there was that task in the Rocket backlog that said, hey, let's switch to tracing from log. So yeah, it seems like that's kind of where everyone's moving towards these days. That's what's most likely going to be best supported. I mean, obviously, you never know. The whims of the Rust community and ecosystem can very quickly sway in a different direction. Like maybe someone invents another new library that's even better or something. I don't know. But I think in Rust, just generally speaking, without things like the reader monad, I think most people are going to lean towards the more object-oriented route of having like a global logging context, which isn't necessarily, you know, what every object-oriented programmer wants. I mean, obviously that's why AOP exists, but I think there's a large number of object-oriented programmers who just don't know AOP or don't care about it, don't want to know, or maybe they do know and they don't think it works for whatever reasons, right? So, yeah, I mean, You never know. You never know if you're making the right decision. It's so hard. I don't want to think about it anymore. So yeah, let's not. Let's just say that's done. It's taken care of. And I'll talk a little bit about what's up for the next sprint. So yeah, I didn't really create the sprint on time. Again, I need to get better at that. I've been kind of dragging my feet. It's because we had a long weekend and everything. But yeah, this is the next task that I want to tackle. It's implementing the config trait. I don't know if I want that to be a trait, because now that I've read that book, it has kind of made me question a lot of decisions I've made. I'm actually happy with a lot of the other interfaces I have in my design doc, but the config trait I don't think I like, because the configuration is something that I'm almost certainly going to be adding more and more features to. The algorithm, right? Like, I don't think I'm going to be changing the algorithm much. Like, we're basically passing in a function to swap algorithms. It's like it's basically like a single method interface or trait, and that's probably never going to change. What's going to happen there is we're going to be passing in different algorithm implementations, so different functions, and we'll execute those. They'll just have to match the right signature, that's all. So there's that. The ROM writer, that interface, that's not going to change pretty much ever. I really doubt it anyway. Like, what? I can't imagine any case where we would ever need to expand the functionality there. Like, if we can write to the ROM file, that's good enough. That's all we need. Same with the random number generator. Like, I'm probably going to be wrapping some RNG library, and I'm going to be exposing the few methods that I will need, which is very likely to be like, man, I don't know, generate bool, generate number, and probably that's it. Right? There'll be very few features that I need from that interface. So I think that's actually going to be okay too. I mean, there's a potential that I might start looking for like range operations and stuff like that. And for that, maybe I could just have like helper functions that call the interface methods. I don't know. Right? Like, it's not... I don't think that's going to be a big deal. So, I think I've covered, like, most, if not all, of the big interfaces I have. We can look at the design doc, actually. Actually, no, I can't. I don't want to do that right now. But, yeah, that, I think, covers basically everything. So, the only interface, or I guess trait, that I don't like is config, because I just know I'm going to be adding new methods to that. And every time I add new methods to that, that's going to mean changing all of the implementations. So any like mock configs will have to be updated. Any real configs will have to be updated. That's like a violation of OCP, right? Open-close principle. It's not really closed to modification and open to change. Or open to extension, sorry. And that's kind of what the book was outlining, and I don't know, I guess I kind of forgot about Solid a little bit when I was designing this. But now that I'm thinking about it, I'm just like, there might be a better way. There might be a better way to handle this. But anyway, I think that's it for today's stream. A very talky stream. Next time, I guess I'll be working on this. I'll be working on this off camera as well, as usual. And, yeah. Hopefully, things go well.